I probably should have just combined this video with the previous one, but video number 7 is just going to briefly tell you the difference between an exponential function and a power function. An exponential function has y equal to a times b to the x. X is the variable and a and b are specific numbers. So for example, and I'm going to write f of x instead of y just to show you another way to write that. 3 times 2 to the x, and usually that's in parentheses like that. Okay, so the base is 2, the exponent is x, and then 3 would be the coefficient. Notice here that the variable x is the exponent. So what we can say is in an exponential function, exponential, x is the exponent. Now, how do we solve this? We have to use logs to solve. Now, how's this different from a power function? In a power function, we have y equals a times x to the b. The variable is the base, not the exponent. Okay, it's the base here. B and a are specific numbers. So for example, I could have f of x equals 3 times x squared. That would be a power function. Now how do you solve that? You don't use logs to solve a power function. So if I have put in a specific value for y, then and I wanted to solve for x, I wouldn't use logs here. I would use radicals or reciprocal powers to solve. In this case, I'd probably just use a square root, but I could also do x to the 1/2 power. So power functions are actually easier to solve usually than exponential functions. Not always. It depends. Most people are more comfortable with roots, but you do have to think about which one you're using. Now, you can solve a power function using logs. We did this in a previous example. We did that, but it just takes a lot more steps. So it's easier to solve a power function. So this is just x to a power. Okay, this is an expression with x to a power. The power, or the exponent, is not a variable in a power function, but it is in an exponential function. So that is the difference between an exponential function and a power function.